Fast radio bursts, often known as FRBs, are one of the most potent and puzzling astronomical phenomena that exist today. These transient phenomena are composed of flashes that emit more energy in a millisecond than the sun does in a few days. While most bursts last mere milliseconds, there have been rare cases where FRBs were found repeating. Although opinions on their causes are still divided and there is no consensus, the number of events that can be studied has been greatly increased thanks to specialized observatories and international collaborations. The Canadian Hydrogen Intensity Mapping Experiment, also known as CHIME, is a prominent observatory that is housed at the Dominion Radio Astrophysical Observatory in British Columbia, Canada. CHIME is a next-generation radio telescope. This telescope is a crucial piece of equipment for finding FRBs because of its wide field of view and extensive frequency coverage. Despite their enigmatic nature, FRBs are common, and the most accurate estimates show that they hit Earth about 1,000 times per day throughout the whole sky. The characteristics of the bursts and the sources cannot all be fully explained by any theory or model that has been put up to far. Despite the fact that some FRBs are thought to be created by neutron stars and black holes because to the high energy density of their surroundings, others still elude categorization. As a result, various theories, from those involving pulsars and magnetars to extraterrestrial communications, continue to exist. The original purpose of CHIME was to detect neutral hydrogen and determine the history of the universe's expansion. Around 370,000 years after the Big Bang, this gas filled the entire universe, and the only photons present were either those produced by neutral hydrogen atoms or the cosmic microwave background, a remnant of the Big Bang. Because of this, astronomers and cosmologists refer to this time as the Dark Ages, which came to an end about 1 billion years after the Big Bang as the first stars and galaxies started reionizing neutral hydrogen, giving rise to the term reionization era. CHIME was specifically created to detect the 21-centimeter hydrogen line, a wavelength of light that neutral hydrogen absorbs and emits. In this manner, astronomers may gauge the rate of expansion of the universe during the so-called Dark Ages and compare it to observable subsequent cosmic eras. However, CHIME has since demonstrated that, due to its broad field of vision and the spectrum of frequencies it covers from 400 to 800 MHz, it is perfectly suited for researching FRBs. Only 29 of the more than 1,000 FRBs discovered so far were determined to be repeating. Additionally, it was discovered that almost all repeating FRBs repeated erratically. The single exception is FRB 180916, which pulses every 16.35 days and was found by researchers at CHIME in 2018. Astronomers found 25 new recurring sources with the use of a novel algorithm. The study also discovered several extremely intriguing qualities that might shed light on their causes and traits. Only about 2.6% of all fast radio bursts that are discovered repeat, according to scientists who said they carefully counted all of fast radio bursts. They have only found a few bursts from many of the new sources, rendering them largely inactive. They are almost as inactive as the sources they have only encountered once. Therefore, they cannot rule out the possibility that the sources, for which they have thus far only observed one burst, will also exhibit repeat bursts. Even though many sources are not highly active, it is feasible that all fast radio burst sources reoccur. Any theory for fast radio bursts ought to be able to explain why some sources are hyperactive while others are generally calm. Future surveys that will take advantage of next-generation radio telescopes that will go into operation in the upcoming years may benefit from knowing more about these discoveries. Radio astronomers might be on the verge of a discovery due to the astounding rate at which new FRBs, including recurring events, are being found.